Hey yo, what is going on? It's your boy. So today we're going to be talking, actually we're going to be expanding a bit more on binomial theorem. And recall that the binomial theorem is essentially a way we can expand binomials. So the rule, or the typical formula is a plus b to the n is equal to, first, we can say it's equal to a to the n plus n choose 1 times a n minus 1 to the b plus n minus 2 a n minus 2 b to the 2 plus n choose r a n minus r b to the r plus n choose n times a n minus n to the b n, where n to the n is simply 1, a n to the n is 1, or a n to the minus n is 1, because recall n minus n is 0, and any number raised to the 0th power is just 1, and then b to the n. So this is your typical binomial theorem formula, and it works for any n. It works for any n that isn't negative / fractional. So in other words, n belongs to the set of all natural numbers. So yeah, that's the binomial theorem. And of course you have your binomial coefficients, which are kind of like combinatorics. So it's you evaluate your binomial coefficient by taking this expression, multiplying things out. You can also use Pascal's triangle, so I'll make reference to that. Or if you have a TI calculator, there's an option to evaluate different binomial coefficients. So today we're actually going to expand a bit more on that thought, more specifically on n being fractional or negative. So let's suppose our power n was fractional. Okay? Let's suppose n was fractional. So for 1 plus x to the alpha, for alpha is equal to p over q, which belongs to the set of all real numbers, right? And this can also be used for, knowing that -1 is less than x less than 1, under the condition that this is a converging sequence, right? This only works if it's a converging sequence. It's given by the infinite geometric sequence. Of, and let me put it down here. So 1 plus x to the alpha is simply 1 plus alpha x plus alpha minus 1 over 2 factorial x squared plus alpha minus 1 alpha minus 2 3 factorial x cubed plus, and then the generalization comes in. We do alpha, alpha minus 1, alpha minus 2, alpha minus 3, all the way to alpha minus r plus 1 all over r factorial to the xr, and so on. And this generalization, this last part here, recall or kind of notice that whatever your denominator is, the last term is being subtracted by a constant 1 less. By a constant 1 less. And if this was 1, we're doing alpha minus 0, which is just alpha. So kind of keep that generalization in mind. We'll just do an example right now. So say I had, say my alpha value was 1/2, okay? How would I do this? Well, pretty simple. I just plug my stuff in. So I do 1 plus 1/2 x plus 1/2, 1 minus 1/2, which is negative 3, 1 minus 1/2, which is negative 1/2, my bad, over 2 factorial x squared. And let's say, because it's an infinite geometric sequence, let's say we just want to find the first 4 terms, right? Because in theory, there are infinite terms, because it's infinite geometric sequence. So let's find the last term, which would be the 4th term. We'd have 1/2, negative 1/2, negative 3 over 2. With every multiple being subtracted with every subsequent multiple being subtracted 1 less. 3 factorial x cubed. So if we kind of work this out, it would be 1 plus 1/2 x minus, right? Minus 1/4 times 1/2, given that 2 factorial is just equal to 2, x squared, plus, oops, my bad. X squared plus 1/2 times negative 1/2 is negative 1/4. Negative 1/4 times negative 3 over 2 is equal to 3 over 8. So plus 3 over 8, given that 3 factorial is just 3 times 2, which is 6, times 1, 6, x cubed. And then if we kind of combined everything together, it'd be 1 plus 1/2 x minus 1/8 x squared minus minus 1 over 16 x cubed, so on, so on. And right here you can see that the common ratio, by the looks of it, I really don't know, but that's just kind of the pattern we see going on with a fractional index. The same principle can be applied in our second instance. Say our n was a negative number. In other words, n was less than 0. Well, what would we do? Well, it's the same principle. All we'd have to do is we'd use this formula. 1 plus x to the n is equal to 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 1 n minus 2 over 3 factorial x cubed, so on, so on, so on. Given that, of course, n is less than 0 or n is negative. So let's do a quick example. Say we had, let's say 1 plus x to the negative 1. In this case, our expanded form would be 1 plus negative 1 to the x plus 1 n minus 1, which is, sorry, this would be negative 1. Negative 1 minus 1, which is negative 2, over 2 factorial x squared, plus negative 1, negative 2, negative 3. And let's just say we want to find the first 4 terms, because this, of course, is infinite. So let's say first 4 terms. So negative 1 times negative 2 times negative 3 over 3 factorial x cubed plus, actually let's find the first 5 terms, because why not? Actually no, I'm too lazy. So these are 4 terms, and notice that every multiple is decreasing by 1 every time we have a new constant to add. So let's expand this. So it would be 1 minus x plus negative 1 times negative 2 is 2, given that 2 factorial is also 2, and that x squared, plus negative 1 times negative 2 is 2, times negative 3 is negative 6, given that 3 factorial is also 6, x cubed. And these cancel out. So simply our first 4 terms would be 1 minus x plus x squared minus x cubed. Hopefully that was kind of helpful. If there are any other questions that seem a bit more complicated, feel free to hit me up. In that case, hope everything works out.